Okay, let's go ahead and finish up your last day of class. Please, I don't want to see any tears. I get emotional when I see you getting emotional, and it's not pretty, okay? So just try to control yourself. Okay, so last day, we're going to finish up chapter 10 and then 2 slides from chapter 12, and then we can, if you're going to talk about the final, if you want to look at the final exam review questions or the bonus exam or whatever, we can do any of that. And keep in mind, your final is in this room next week, Tuesday at 1:30. All right? Okay, so before we get started, are there any questions? No more questions?
Oh, you want to set, can you get the free bonus points for the exam?
No. But yeah, you do. We've got the bonus
No,
test.
like, if you show up today, like, give us points.
You're reaching there now.
I tried.
I know you did. That's good.
I had to come up with something to put me on the spot.
Okay, good question. Other questions? All right, now let's go ahead and finish chapter 10. Chapter 10, we've been talking about ways to analyze capital budgeting projects. So we've went through some different techniques. We went through the payback period, the net present value, the profitability index, and the internal rate of return. You will see problems like that on your bonus tests. Okay, I mean, you know it's coming. Okay, so if you can work the problems that we talked about in class or the practice questions that are on Canvas, you should be good to go. Now, some of the theory, there's also some theory, because a lot of times people see that and they think, well, the bonus test is going to be all calculations. Well, it's not. There's some theory questions. And one of the things that we talked about on Tuesday, where we ended up, when we calculated net present value, looking at projects A and B that we've been using in chapter 10, net present value for project A was higher than for project B, so it would be preferred. When we calculated internal rate of return, the internal rate of return for project B was higher than project A, so it would be preferred. And so that's what this slide is talking about. It's talking about conflicting rankings in terms of if you're using multiple techniques to determine the suitability of a capital budgeting project, which most companies do, which one is right? Because this shows us kind of what we found here. B had a higher internal rate of return, and NPV for A was higher. So basically, it's saying, what's the deal here? What's happening? Now, pretty important here. So this is not unusual, and this is also pretty important here. It says when it comes to ranking, there's no guarantee that net present value and internal rate of return is going to rank the projects the same. You may have 5 projects, and you may have different rankings depending on the method that you use. But when it comes to a project being acceptable or not acceptable, you will always get the same answer no matter which of those 2 methods you use. It just has to do with the ranking. So if you have a limited amount of capital, then you may get some different solutions. Now, the reason for this is here in red. Okay, you can pretty much count on, if you see something in red on the bonus exam slides, you probably need to know it. Okay, so it says net present value and internal rate of return can result in conflicting rankings due to two things. One is the magnitude of the cash flows, or the size of the cash flows, and secondly is the timing of the cash flows. Now, if you go back and take a look at Project A and Project B, Project A had the $42,000 cash outflow, and then it had if my memory is correct, $14,000 per year for 5 years cash inflows. Project B had $45,000 flowing out for the initial investment. It had the big $28,000 cash flow in year 1, and then $12,000 in year 2, and then only $10,000 in years 3, 4, and 5. So the size of the cash flows was completely different regarding Project A and Project B. And that's why you get the difference in the rankings of which one is best depending on net present value or internal rate of return. Now, one other thing that you need to be familiar with here is regarding what happens to the intermediate cash flows. What are the assumptions that these two methods use? And you can tell, since we're talking about net present value and internal rate of return, those are typically the two, I guess, most technically correct methods, although we'll talk about one is actually the most correct. This is referring to whenever you invest in a project. For example, Project A. We spend $42,000 today, and then it brings in for us $14,000 per year. This is referring to intermediate cash flows, and the intermediate cash flows are the cash flows that flow in. It's that $14,000. And when that comes into the company doesn't just put it in a drawer somewhere and lock it up. They reinvest that money into another project. Now, the assumptions here for net present value, it says that NPV assumes intermediate cash flows are reinvested in other projects and they earn at least the cost of capital, the cost of raising the money. That makes sense. Okay? That is a correct assumption to make. The internal rate of return assumes that these intermediate cash flows are reinvested at that last project's internal rate of return. So for example, for Project A, we had a 19 point something % internal rate of return. So it's saying the next project is going to have a 19 point whatever internal rate of return. That's not accurate. Now, it may have an internal rate of return higher than the cost of capital, but it may be 14%, 16%, 12%, whatever. So this is an incorrect assumption. So you need to know that. Net present value, intermediate cash flows reinvested at the cost of capital, correct. Internal rate of return reinvested at the project's internal rate of return, which is incorrect. And you will see a couple of questions probably related to that on your bonus test. Does that make sense? Kind of what I know it's the last day of class, and talking about capital budgeting on the last day of class is tough, but just stick with me here. All right. So basically, which of these is better? Okay, so on a purely theoretical basis, net present value is the better approach. It is technically better. You don't really have to get into this a lot, but the reason for it is it measures how much wealth a project creates, and because of some mathematical properties, the internal rate of return can actually come up with multiple solutions. If you remember back, probably a while back for some of you, you studied something called the quadratic equation. Does everyone remember the quadratic equation in your math classes? And you thought, where am I ever going to use this? Well, actually, because of the quadratic equation, when it comes to the internal rate of return, you can have multiple solutions. Remember, with the quadratic equation, you had two solutions. Does anybody remember what the formula is for that? What is it? Excellent job. Good job. Okay, so that plus or minus, okay, that gives you multiple solutions. So what this is saying is, when it comes to capital budgeting projects, if the signs of the cash flows change more than once, so if we go from a negative cash flow, which is the initial investment, to a positive cash flow, and then if at some point during the life of the project it goes back to negative, so the signs are changing more than once, you could have multiple solutions and you're not really sure which one is correct. So this says that theoretically NPV is better, but a lot of times managers prefer the internal rate of return because the solution is given as a percentage. So what you kind of, I think, can see from all of this capital budgeting information is, we talked about the payback period. We said the payback period has a lot of stuff wrong with it, but a lot of companies use it because it's simple. It's easy to understand. Anybody can understand it. The internal rate of return is not technically the correct method to use, but a lot of people use it simply because the solutions are given in a form that they like, okay, in percentages. So when it comes to capital budgeting, there's a lot of variables. Not everybody is really good at capital budgeting, but if you're the person that is, you can make a lot of money working with capital budgeting projects and doing this analysis for corporations to determine if a project is suitable or not suitable. All right. Skip past this. All right, so now chapter 12. A couple of slides here from chapter 12. This is really simple. There's no calculations involved here. What this is referring to is simply how do we adjust for risk as a corporation if we're undertaking a project that is riskier than a normal project. And I use different examples when I go through this. I've got Nike here, so I'll use Nike in this example. Now, Nike Corporation does what? What do they make? What do they sell? Shoes, apparel, athletic gear. I mean, you can buy anything from basketballs to shoes to all kinds of clothing, outerwear. I mean, tons of stuff. So let's focus on the shoes. Okay? Nike's been around for a long time. They have been very successful. They have introduced lots and lots and lots of new shoes. So let's say that Nike's going to undertake the design and the introduction of a new shoe. Is that anything out of the ordinary for Nike? No. They've done it hundreds and hundreds of times. So that is what we would call an average risk project. They know all about it, so there's no risk involved, or there's no more risk involved than average. But what if Nike's board of directors, they're sitting around one day and they're thinking, you know what, this shoe thing, this athletic thing, everything's going technical. Everybody's getting into the wearable technology, and maybe we should just jump on into the technology market and introduce our own brand of tablet computers, or maybe even cell phones. And we can have them in bright colors, and we can have the Nike swoosh on the phone or the tablet computer, and that way people, when they look at it, they'll think it's really fast. I mean, it might work, but there's a problem with that. Nike has never manufactured or sold computers or phones. So if they decide to undertake this project, it's going to be an expensive project. They're going to spend a lot of money on this. It's a capital budgeting project. It is riskier than normal. It can be a lot riskier than normal. So we have to decide, okay, how are we going to account for that increased risk when we analyze the suitability of this capital budgeting project? So there's a couple of different ways here. So this is all you need to know about these two risk adjustment techniques. Okay, so there's two listed here. One is called the certainty equivalent method. And basically the certainty equivalent method uses something called a certainty equivalent factor to essentially make the cash flows that we expect to flow in from, say, these computer sales by Nike, it makes those cash inflows smaller, more conservative. And so if we multiply these cash flows by this certainty equivalent factor, which is going to be less than 1 for an above average risk project, so the lower the certainty equivalent factor, the riskier the project. Now, it's pretty simple. If we, for example, if we have, let's say, we expect to have a $100, if this is working, okay, here we go. So if we expect to have a $100 cash flow come in from the sale of our computers, and we want to use a certainty equivalent factor of 0.7, that means we're going to make this cash inflow smaller, more conservative. Now it's only $70. So if we take the present value of these more conservative cash inflows, go through our, for example, our net present value calculations, and it still comes out to a positive net present value, we have accounted for the increased risk. It's still a good project, and we would undertake that project. So this would be the certainty equivalent factor, okay? So it's going to be, again, less than 1, and the smaller the factor, for example, if it was, 0.4, you can see how much smaller it would make the future cash flows. So it's just mathematical. We're dealing with or changing the numerator of the net present value formula. So that's one. The second way we can do this is something called the risk-adjusted discount rate. The discount rate is the denominator of the net present value calculation. And this is pretty simple. If we make the discount rate larger, it's going to make the present value of the future cash flows smaller. Again, we're making them more conservative, we're making them smaller, but if we can use a higher discount rate, make the present value of the cash inflow smaller, subtract the initial investment, and still have a positive net present value, again, we've accounted for the risk. It's still a good project, and we would undertake that project. Now, a couple of things to know here. The certainty equivalent method is theoretically preferred because it separately adjusts for risk and time, and the risk-adjusted discount rate method is typically most often used in practice because it's just really simple. Again, people understand making your denominator larger is going to make your present value smaller. Okay, so questions about any of this from chapter 12? I mean, that's all we're covering. I'm assuming it's still chapter 12. Is that chapter 12 in your new book? Anybody have their book? I've got to admit, I haven't looked, okay? I probably should have opened my textbook and looked, but I haven't, so I'm assuming it's still chapter 12. Okay, so are there any questions about any of this exciting material before we move on and talk about your final exam? All right. All right, now let's jump down here for a second. Let's take a look at your study guide first. And this will point out for you what's going to be on your final. Now again, we kind of jumped around here. Chapter 6, we covered most of chapter 6. The only thing we left out was the interest rate information. We talked about bonds in chapter 6. Chapter 7 was the stock valuation chapter. So we talked a lot about that. We left out the non-constant growth model in chapter 7. So for example, in chapter 6, we talked about valuation. What are some valuation inputs? What's the basic valuation model look like? And then we converted that to valuing a bond. And then we talked about bond value behavior, and that was if a bond sold for a discount or a premium, why was that? And then we talked about the yield to maturity. So what is the yield to maturity? How do you calculate it? So that was from chapter 6. Chapter 7 was a stock valuation chapter. So we talked about undervalued versus overvalued stocks. What is the efficient market hypothesis? How do you value common stock and preferred stock? We talked about two different models, the zero growth model and the constant growth model. So I said we're going to leave out the non-constant growth model. And then also some other approaches to common stock valuation. So if you have a chance, take a look at those, okay? And then the last part of your final exam covers chapter chapter 10, the first 6 slides from chapter 10, and then a few slides from chapter 11. And that's when we started talking about the capital budgeting stuff. Okay, so the definition of capital budgeting, definitions of a capital expenditure, a current expenditure, what are the key motives for capital expenditures? These are pretty simple. The 2 major ones are expansion or replacement of a project or an asset, and independent versus mutually exclusive projects, and then unlimited versus capital rationing. Okay, so that was all, I believe, the first 6 slides from chapter 10, and then we jumped to chapter 11, and we went into basically talking about cash flow and the cash flow components of a capital budgeting project. So we said we have an initial investment, we have operating cash flows, and then occasionally we have what's called a terminal cash flow. That's at the very end of the life of the project. And we went through, basically that's what all of this talks about. And then the bonus test, which is from chapter 10, slides 7 through 30, and then 2 slides from chapter 12, that's what we just got through talking about, and that's how to calculate the different techniques regarding capital budgeting. Payback period, net present value, profitability index, and internal rate of return. So you need to know how to calculate all of those. Know why net present value and internal rate of return can result in conflicting rankings. We just finished talking about that. Know why NPV is theoretically better and why the internal rate of return is the most popular. What is the certainty equivalent method? What is the risk-adjusted discount rate method? And then the definition of risk. I don't know if we talked about that or not. I can tell you this. Risk, as given in chapter 12, is the certainty of receiving the cash flows associated with a project. Okay, so the certainty associated with receiving the cash flows associated with a project. And that's where we said, with the Nike computer example, those cash flows would be less certain if Nike is selling computers as compared to if they are selling shoes. Because again, they have more experience selling shoes. And that basically is it for your final exam. So are there any questions about the study guide itself? All right. Okay, now it's kind of up to you now. What do you want to look at some of the practice questions for the final exam that are listed here? Okay, so the final exam, here's your formula sheets, and then here are the practice questions. So we can look at some of those if you want to, or yes. Yeah, the final exam is going to be just like it's been all semester, 50 questions, multiple choice. I'm trying to think if there's no true false, I don't think. So it's all multiple choice. And then the bonus test will be 15 questions, again, all multiple choice.
Are we going to get our formula sheet on the test like we've been getting?
Yeah, and there's only like, I don't know, there's not very many formulas. I mean, there's like 3, maybe 4. 3, okay? So there's not many, okay? Now, this one, what was that? Can you have a note card? You can, as long as these are the only things you have on it. Yeah, I'm fine with that. But this is the zero growth model, the constant growth model, and then this is going to be on your bonus test. So what you would do is you would just tear the formula, it'll probably be on your final, tear it off, hang on to it for your bonus exam. So the way it'll work is you will take your regular final, you will finish it, you will turn it in, I will hand you a second test, your bonus test. It'll have 15 questions on it. You will then take it, turn it in, and you are finished with Finance 330. So pretty straightforward, pretty simple. Okay, so I saw a couple of you nod your head. I saw some of you shake your head no when I mentioned going over practice problems. But since we're here, we might as well go over some of these. And we'll just hit some of the high points. I mean, some of it's just theory question, so you're not going to have any trouble here. You'll notice the solutions are given to you, the answers are given to you after each question. So again, a lot of this is basically just straightforward. Now again, you may see some of these questions on your final exam or on your bonus test, so I would suggest taking a look at these and knowing the answer to at least the ones that are listed here. Okay, so some of this is pretty straightforward. So I'm going to go through to the calculations actually, or if you see any of these questions that you aren't sure, why is this the answer, then that's fine. I'll be happy to talk about it. So I'm going to jump through the first few. It starts out talking about bonds, and then okay, so here's a bond valuation question, question 7. So we can work through that really quickly. It says, question 7 says, a firm has an issue of $1,000 par value bonds with a 9% interest rate. The issue pays interest annually, has 20 years remaining to maturity. If bonds of similar risk are currently earning 11%, the firm's bond will sell for how much? Okay, now first of all, in looking at this, you've got 4 answers listed here, 4 possibilities. This bond is paying a 9% coupon. Current market rates for a bond like this are 11%. So is this bond, because interest rates have gone up from 9 to 11, is this bond going to sell for more than $1,000 or less than $1,000? Because if interest rates go up, what happens to bond prices? They go down, okay? So automatically, you know that A is not correct and D is not correct. So we've got B and C to work with. Our inputs, again, with bonds, we have 4 inputs. So for this bond, let's see, I've got a blank one of these. Probably would have been faster if I'd have worked it out. All right, so for this one, your inputs, you're going to need a future value, which is 1,000. N is 20. The I/Y is 11. And the payment is 9% times 1,000, which is $90. And what we're looking for here is the present value of these future cash flows, which is going to be the selling price of the bond. Okay, that's 1,000, by the way. That's not 1,060. So if you're looking at this, 1,000. All right, so pretty straightforward, pretty simple. If we bring up our financial calculator, again, it should be set on 1 payment per year. All right, so let me check this. Okay, so there I'm set there, and I'll go through the clear process. Second, clear time value of money. Second, clear work. And then I'll put in the information. 1,000 is the future value. 20 is my N. 11 I/Y, and 90 is my payment. So I have my 4 inputs. I want to solve for the present value, so I'll press my compute key and the PV key, and it tells me this bond should be selling for $840. Now you'll notice it's off a few cents. It's off 7 cents, 6 cents, due to rounding, because the answer here says $840.67. But that's just because of the way they calculate it. So everybody remember this? I know it was before Thanksgiving. Been a while. But again, pretty simple, pretty straightforward, hopefully. Let's see. Okay, here's a yield to maturity problem, number 9. Now, remember, with yield to maturity, what you're calculating, you're computing the I/Y. The yield to maturity is the rate that you're going to earn if you buy a bond at a specific price and hold it until it matures. So we need to know the price of the bond, the future value of the bond, the number of periods until maturity, and the payment amount. And we're going to compute the I/Y. So in this case, let's see, this bond has a $1,000 par value, 15% annual coupon interest rate, 10 years to maturity, and $1,250. All right, so if you're calculating this, basically the only thing that you need to keep in mind, a couple of things. One, if you've got a future value given to you and a present value, the present value has to be entered as a negative, okay? If not, you're going to get an error 5 message on your calculator. So N was 10 and the payment was 15%. So 15% of 1,000 is $150. So we're looking for the yield to maturity. It's going to be a percentage. Now, we went through yield to maturity calculations in class, and we said if a bond pays interest annually, then once we get the solution, we don't have to make any adjustments to it. But if a bond pays interest semi-annually, 2 times per year, and we change everything on our inputs to 6-month increments, once we come up with the solution, then we have to multiply that by 2 to get the actual annual rate, which is the yield to maturity, because the yield to maturity is always a yearly or an annual rate of interest. So if we have this information, enter it into our financial calculator. Which seems to have disappeared. Let me find it again real quick. All right, so again, I'm going to go through the clear process. 1,000 is the future value. 1,250, we're going to make it negative here. Press the present value key. 10 is my N, and 150 was my payment. So we have our 4 inputs. We want to compute, in this case, the I/Y, which it tells us if we buy this bond for $1,250, hold it until it matures, we're going to earn a yield each year of 10.79%, which matches answer A. So any questions about this? Everybody getting the right answer? All right, let's see, number 10. Is this a calculation or not? 10% 10-year maturity. Bond F, 10% 10-year maturity. Market return for each bond is 10%. Okay, so read through. Let me show you question 10. You could calculate this if you wanted to, but actually you don't have to, knowing what you know about bond value behavior. So when looking at this, tell me why answer A is correct. You can see the answer given to you, but tell me why answer A is correct. Okay, because expand on that a little bit. Everything by meaning, what do you mean by everything? Okay, so each bond pays a 10% coupon rate, and the current market rate of interest or the required return for each bond is 10%. So that was the very first example that we went over in class when we got the bond valuation, is we looked at a bond, it paid a 10% coupon, the market rate of interest or the required rate of return was 10%, and so that bond equals exactly $1,000 in value because the required return equals the coupon rate. And then we talked about what happens if the required return is higher than the coupon rate, the bond would sell at a discount. What happens if the required return is less than the coupon rate, the bond would sell at a premium. Now, if you wanted to, you could go here and calculate the price of each of these bonds, and you'll find they're $1,000. Okay, either way works. It's just, if you understand bond valuation and the theory behind it, then you could probably tell there was no difference in the price. All right. Let's see. Okay, so now we're talking about stocks. Here's a pretty straightforward one. Number 12, 8% preferred stock with a market price of $110 per share and $100 par value pays a cash dividend of. Now with preferred stock, it pays a percentage of the par value. So this is simply going to be 8% of $100 par value. 8% of 100 is $8 in dividend. So the answer would be B. Let's see, 13, preferred stock valuation. They have preferred stock, pays a dividend of $4. The required return on the preferred stock is estimated to be 16%. The value of the preferred stock is, now, we said that preferred stock is valued just like a zero growth common stock because the dividend does not change. So in this case, this stock is going to be paying an annual dividend of $4 forever. So we can use the zero growth model, which simply says that the price of a stock at time period 0 is equal to D1 divided by either K or R, depending on which one we're dealing with, but that's the required return. So in this case, that's going to be $4 divided by 0.16. And I'm assuming, since it says the answer is C, I'm assuming that's $25 even. Okay, let's see. Let's take a look at a couple more. Number 14. Now again, as you read through these, you can tell which model should I use. Number 14 says a firm has experienced a constant annual rate of dividend growth of 9%, and it expects dividends per share in the coming year to be $2.70. The firm can earn 12% on similar risk investments. The value of the firm's common stock is. Okay, so this is number 14. All right, so for number 14, the constant growth formula is this. D1, the next dividend to be paid, divided by K, which is the required return, minus G, which is the constant growth rate. So we just fill out the information. It says the next dividend to be paid is $2.70 divided by 12% required return minus the growth rate. And so you should come up with $90 per share. And number 15 is exactly the same. Okay. All right. So let's see, any others really quickly. Okay, so number 15 is also a constant growth calculation. Let's see, expected dividend next year. Now, here's a question. Let's say this last one that we looked at, instead of being worded that it expects to pay a dividend per share in the coming year of $2.70, what if it had said it recently paid a dividend of $2.70? And what adjustment will we have to make to this 270 to fit the constant growth model? Because we know that the dividends are growing at a constant 9% per year. The formula is we want the next dividend to be paid. So if the wording is you're given the last dividend paid, you would multiply if the 270 times 1 plus the growth rate, 1 plus 0.09 in this example, to come up with the next dividend to be paid. So again, the wording of these is really, really important. This one is worded the same way. It's expected dividend next year of $3. So that's what we want. That's D1. But if it read, it just paid a dividend of $3, then we would have to adjust it for the expected growth. All right. Okay, so some more theory questions. Okay, so this one's pretty straightforward. This is a payback period. And it actually doesn't get real specific here. It says a firm is evaluating a proposal with an investment of $35,000. The cash flows are $10,000 the first year, $20,000 the second year, and $10,000 the third year. The payback period is pretty straightforward. With the payback period, we simply start adding up the cash flows to see when's it going to pay for itself. So the first year, it doesn't pay for itself. The second year, we're up to 10 plus 20, which is 30,000. So we can see that the project is going to pay for itself somewhere between year 2 and year 3. What's the exact payback period for this, by the way? The formula is the year before full recovery, which is year 2, divided by what's still needed, which we're up to 30. We need 35 to pay it back, so we need to have 5,000, divided by the cash flow during the year, the third year, which is 10,000. So the exact payback period is 2.5 years for this project. Here's one. There's really no calculation, but you need to understand this. Firm is evaluating 3 capital budgeting projects. The NPV for each are given. Which of these projects would you accept and which ones would you reject? Again, this was pretty straightforward. We said a net present value project is acceptable if the NPV is 0 or positive. So in this case, we would accept projects 1 and 2. We would reject project 3. So answer A is correct. Let's see. Okay, we should work one of these just to make sure you understand the cash flow. 5,000, 1.8, 1.9, 1.7, 1.4. Okay, this will be pretty quick and easy because this is a net present value problem, number 25. Number 26 is an internal rate of return problem, but they have the same cash flow. So we can calculate both of them by just putting in the cash flows one time. So I'm going to go from what I printed out here. All right, so we're going to, for this, we're going to go to our cash flow register, the CF key. Now, once I'm here, I'm going to press the second and the clear work button in the bottom left-hand corner to clear out any old cash flows. And it tells me for number 25 that the initial investment is $5 million. So I'm going to put in here at time period 0, 5 million. The initial investment is negative, so I'm going to make it negative here and then press the enter key. So that's what I'm spending. Now, if I press my down arrow key, I can just start entering the cash inflows when they occur in years 1 through 4. So year 1, it says we're expected to have 1.8 million. So 1,800,000. I'll press the enter key to lock it in. The down arrow, the frequency is 1, which is correct. So I'm going to go to cash flow 2, which is 1.9 million. Press the enter key. Down arrow, cash flow 3, which is 1.7 million. And then cash flow 4, which is 1.3 million. Now, once all my cash flows are in and I've pressed the enter key to lock them in, I can press my down arrow key. It'll take me to cash flow 5, which should be 0, and then it'll take me back around so I can take a look at all my cash flows. Okay, now 25 wants us to calculate the net present value. So to do this, once my cash flows are in, I'm going to press the NPV key. I'm going to enter the discount rate, which is the cost of capital, 15%. So 15, enter. Press the down arrow key one time and press your compute key. And it tells me that the net present value should be 137,000. Negative $137,052. It's kind of easy to miss the little negative sign here. Okay. So would this be an acceptable project or not? No, because if we accepted this project, it would destroy $137,000 worth of stockholder wealth. Now, number 26 gives you the same cash flows, but asks you to calculate the internal rate of return. Once we've got the cash flows in, all we have to do is press the internal rate of return key and press the compute key. And it tells us the internal rate of return is 13.57%, which is less than the cost of raising the money, which is 15%. So again, this would not be an acceptable project. Okay. Is there anything else? Okay, 27 is another yield to maturity problem. 28 is a semi-annual bond valuation problem. That's where you simply divide the coupon payment by 2, multiply the years to maturity by 2, and divide the market interest rate by 2. Number 29 is a semi-annual yield to maturity problem. So again, you divide and multiply your inputs by 2, and then once you get your solution for number 29, you need to multiply it by 2 to come up with the annual rate. And the rest of them are just basic stock valuation problems. So there are 37, I don't know how I came up with 37, but 37 total practice problems for your final exam and your bonus tests. Okay. All right, so final questions. What? I will. Yes, I'll be in the office. I will be in my office Monday afternoon. If you have questions, I'll be in there before the test. I'll be in there, I think. I've got a meeting Tuesday, but I should be back and in there probably by 10:30 or 11. So if you have questions, email me, stop by. If my door is closed, be sure to knock on it to make sure I'm not in there with the door closed working. Otherwise, study hard. I've enjoyed having you in class this semester. I will see you on Tuesday. We'll get this knocked out. Everybody have a good and safe weekend.